The topic for page 14 and 15 is scientific notation. And standard form. So hopefully you've seen scientific notation in a science class, probably, and maybe in some math classes. So scientific notation is a compact way, so basically squishing it together, of writing very large or very small numbers. So if you can see down below in 1 through 10, we've got some pretty big numbers and some pretty small, meaning very, very small decimals. So instead of having to write those all out, it's a shorter way if you write scientific notation. So scientific notation has a number times 10 to some other exponent. The times 10 is because we're multiplying it by 1,000, 1,000,000, whatever it might be, or we're dividing by that much, which is where the negative exponent comes into play. Here's the important part about our first number. It can be exactly 1, but it cannot be 10 or greater. It has to be a single digit before the decimal. So you will have a decimal usually, and then your front number needs to be between 1 and 10, but it can include 1. So here it has the steps. If you have a standard form, it's just our regular numbers, and moving it into scientific notation. You move the decimal, so the new number is between 1 and a number up to 10. So you have to have one number and then the decimal point. Then you're going to write your power of 10 so that the exponent matches how many times the decimal was moved. If the decimal was moved to the left from the original position, then you have a positive exponent. If the decimal was moved right, then you have a negative exponent. So when you have very large numbers, you don't usually have a decimal. So you have to know to put the decimal in the back. And we could add zeros if we really wanted to, but we don't need to. So we start with the decimal there and we move it left twice to get it between the 5 and the 4. So this is 5.4 times 10. We moved it left twice, so positive 2. So for number 2, we put our decimal here. We have to move it 1, 2, 3, 4, 5 times. 9.37 times 10 to the 5th. So if your standard form number is greater than 1, so a really big number, you're going to have a positive exponent. Sometimes you don't have to think about moving the decimal. You can just say, okay, I know it needs to be right there. So 1.852. And then you can count 1, 2, 3, 4, 5, 6. If you don't like doing the little swoops, you can actually just count the numbers behind the decimal. 1, 2, 3, 4, 5, 6. So 1.852 times 10 to the 6th. This one here, the decimal needs to go there, 7.682. 1, 2, 3, 4. So times 10 to the 4th. Again, if you would rather put the little swoops in, you can do that. This one's a little bit weird because it's only in the thousands, but you can still do 4.671 times 10. So here's my decimal, 1, 2, 3 to the 3rd. So notice all of those standard numbers are bigger than 1, so all of our exponents are positive. Now, when all of our numbers are less than 1, so these decimals, our exponents need to be negative. So we need to move the decimal 1, 2, 3 times. So 9.82 times 10 to the negative third. We move the decimal right, so it's a negative exponent. Or also our standard form is less than 1, so it needs to be a negative exponent. Here we actually only move it 1, 2. 5.273 times 10 to the negative 2. If I put my decimal in first, 1.4, 1, 2, 3, 4, 5, 6. 1.4 times 10 to the negative 6th. Again, you can just count the numbers in front of the decimal this time. 1, 2, 3, 4, 5, 6. You don't count this 0. This one's really weird. You just move it once. 2.58 times 10 to the negative 1. Our last one, 7.25 times 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So to the negative 9th power. So if your standard form is greater than 1, you're going to have a positive exponent. If it's less than 1, you're going to have a negative exponent. You can only have one number in front of your decimal point in order to be scientific notation. So that's going to help us with the next part. It says determine if the number is correctly written in scientific notation. So that's what you need to look for. Is there only one number in front of the decimal point? So number 11 is fine because it has the 2.98. So that one is yes. Number 12 is no. It has an 11. It can't have an 11. So we need to move it back to the left. 1.14 times 10. That means we need to add 1 to our exponent to get to the fourth. When you make your number smaller, you actually need to make your exponent bigger. So when you go left, you need to add 1 to your exponent. 13, same thing. It is not in scientific notation because it's 85. So we need to move it left 1, 8.51 times 10 to the negative fourth. You add 1 to your exponent, so you get 10 to the negative fourth. 14 is fine because it is just a 6 in front of the decimal.